asks us to find the inverse of the function. So to find the inverse, we have to take the original equation, which is y equals 1/3 x plus 9. And what we want to do to find the inverse, we're going to switch the x's and the y's. So it becomes x equals 1/3 y plus 9. And then to write it in inverse form, we've got to solve for y. So the first thing I would do is subtract 9. And then to get rid of 1/3, I'm going to multiply by 3. So multiply this side by 3. So it would be, this cancels out. Y equals 3 times x minus 9, which is 3x minus 27. So to write it in inverse form, the inverse of f of x equals 3x minus 27, which is a. Number 31, the cube root of x minus 1. So this original problem is y equals the cube root of x minus 1. So this becomes x equals the cube root of y. Doesn't look very good. Cube root of y minus 1. I've got to solve for y. So I add 1. And then to get rid of the cube root, I cube it. And so I'm going to cube this side. And luckily, looking at the choices here, I don't actually have to expand that. I can just write the inverse of f of x is equal to x plus 1 cubed, which is c. It is not x cubed plus 1, because what you would have to do is you have to write x plus 1 down 3 times, and then you'd have to do distributive property, or FOIL as you like to call it. Alright, find the value of the log of the expression. Now you can use your calculator to do log base, that's fine, but this is basically asking 2 to what power would be 1/16. Well, that would be 2 to the negative 4th power, because 2 to the 4th is 16th, so if I want it to be in the denominator, it's going to be negative 4. You can use your calculator, you can use change of base, you can type in log of 1/16 divided by log of 2, and you should get negative 4 that way. You can just do it in your head, that's an option. You can also, if you have the log base key on your calculator, you can use that, and you can put the 2 in the base, and then the 1/16 right there, and it'll evaluate it for you. Alright, so log base 6 of the square root of 6 is the same thing as saying log base 6 of 6 to the 1/2. The square root is the same thing as 1/2 power. Now I take that 1/2 off and move it to the front, and log base 6 of 6, so in log base 6 of 6 is 1, so it's just 1/2 times 1, which is 1/2. And then same thing for 34, natural log of e to the negative 5th. Take the negative 5 and bring it to the front. It becomes negative 5 natural log of e, so that's negative 5 times 1, which is negative 5. So it's D. Alright, number 35. They want us to solve this exponential equation. You can write them both as powers of 2, and I did that when I solved one similar like this in a previous video review, or you can log both sides, and that might be, that's what I saw some of you guys doing. Log of 4 to the x plus 2 equals log of 8 to the x. Alright, move this to the front, and I would get x times x plus 2 times the log of 4 equals x times the log of 8. I'm just going to go ahead and use my calculator. What is the log of 4? Actually, I don't have the calculator open. Alright, the log of 4 I need the log of 8. So for the log of 4, I'll put 0.6021. So I'm going to do x plus 2 times 0.6021 equals x times 0.9031. Whoops. 0.9031. Now I can just solve this. So 0.6021x plus 2 times 0.6021, which is 1.2042. That's just distributing, doing 0.6021 times both equals 0.9031x. Subtract 0.6021x from both sides. I get 1.2042 equals 0.9031 minus 0.6021 is 0.301x, divide, and I get basically rounded x equals 4. Another option with this same problem would be to rewrite 4 as 2 squared, and then rewrite 8 as 2 cubed. So this side becomes 2 to the 2 times x plus 2, and this side becomes 2 to the 3 times x. Then you could drop off the 2's, and you're just doing 2 times x plus 2 equals 3x. You can also do it that way. For 36, you're going to, with an e, you're going to natural log each side. And then what you're going to do is you're going to bring this negative t to the front. So negative t times the natural log of e equals the natural log of 0.02. So that's just negative t times 1 equals natural log of 0.02. So the natural log of 0.02 is negative 3.912. And so I get negative t equals negative 3.912. So t equals 3.912. That would be D. So the answer to 35 would be A. The answer to 36 would be D. Problem 37. They want us to solve these logarithmic equations, 37 and 38. Before you can solve them, because I was talking to somebody today and they said, well, you can just drop the log off of both sides. Well, you have to have a single logarithm. So what we're doing here is, since there's a plus, we can combine that into a multiplication problem. So 2 times x plus 2. Now I can drop log off of both sides, and I get 3x equals 2 times x plus 2, which would be 2x plus 4. Subtract 2x, you get x is equal to 4. I go back and make sure it works. This side would be the log of 12, and this side would be the log of 2 plus the log of 6, which is the log of 12, so it works out. And you can try it on your calculator. Alright, for 38, on the left side, since it's a minus, you're going to make it a division problem. 4 plus x on the top, and x minus 3 on the bottom, and then over here you've got log of 2. So I can again drop log off both sides. So I get 4 plus x over x minus 3 equals 2. Multiply both sides by x minus 3, and you get 4 plus x equals 2x minus 6, which would be, move this x over here, add 6 over here, you get x is equal to 10. And again, go back and make sure it works. Plug it in your calculator, type it in, and make sure you get equivalent expressions on both sides. You can also use your calculator, put this in the y1, put this side in the y2, and find the intersection point. That's another option to find an answer. 39. How long will it take for the population of a certain country to double? If its annual growth rate is 2.2%, round to the nearest year. Alright, let's talk about doubling rate. Natural log of 2 equals k times t. K is your rate, t is your year. So what I know here is I know the rate is 2.2%, so that's 0.022, and I want to find t. So divide by 0.022, and it's going to be the natural log of 2, close my parentheses, divided by 0.022, and I get 31 and a half years. So they're going to say that it's going to take about 32 years to double, for the population of that country to double. Last problem on the review, a sample of 800 grams of radioactive substance decays according to this function that they give us, where t is the time in years. How much substance will be left in the sample after 30 years? So all you're going to do is take this function and plug in 30 for t. So 800 times e to the, alright, let's see if I can get this right, negative 0.036, negative 0.036 times 30. It was 30 years, right? 30 years, and this will be the amount that's left, so enter. I get, they started with 800, that's how much you started with, so there's going to be about 272 grams left after 800 years. I mean, after 30 years, sorry, they started with 800 grams, so we're down to 272 after 30 years. So that's all the review, and I wish you the best. Let me know if you have any questions about any of these.